Have you ever wondered what your glasses, your car's headlights, and even bulletproof glass have in common? They all rely on a special type of plastic that is so strong it can stop a bullet. But how is such a material even possible? In this video, we're diving into the world of specialty polymers. Specifically, we'll be exploring a group called engineering thermoplastics. We'll start by understanding what makes these materials so different from everyday plastics. Then, we'll shine a spotlight on one of the most famous members of this family, polycarbonate. We'll see exactly how it's made, what gives it its incredible properties, and where we use it to build our modern world. Ready to uncover the science behind superplastics? Let's begin. So let's start with the basics. What exactly is an engineering thermoplastic? Formally, engineering thermoplastics are a class of plastic materials that offer superior mechanical and thermal properties compared to common commodity plastics. Okay, let's make that simpler. Think of regular plastics, like the kind used for grocery bags or disposable water bottles, as simple wooden blocks. They do their job, but they're not very strong or durable. Now, imagine building blocks made of high-grade steel or aluminum. That's what engineering thermoplastics are like. They are the high-performance versions of plastics. They are designed to be tougher, stronger, and able to withstand much higher temperatures and stresses. They're meant for jobs where regular plastic just wouldn't survive. On a molecular level, they are still long chains of molecules, or polymers, but these chains are often more robust and packed together in a more organized way, which gives them their superior strength. You'll find them in places that demand high performance. Think about the internal components of your car's engine bay, the durable casing of your power drill, or critical parts inside medical equipment. These are all applications where strength, heat resistance, and reliability are not optional. All right, now that we have a feel for the category, let's zoom in on our star player, polycarbonate. Polycarbonate is a thermoplastic polymer whose chemical structure contains carbonate groups. This specific structure is the secret to its amazing properties. In our building block analogy, polycarbonate is a specialty steel block that is also perfectly clear. It's a material that has the transparency of glass, but the impact strength of metal. It's created by reacting two different smaller molecules, or monomers, over and over again. The first is called bisphenol A, and the second is phosgene. When they link together, they form the super strong chains of polycarbonate. So, how does this reaction actually happen? It's a process called condensation polymerization. We start with our two monomers. Bisphenol A has a reactive group on each end, and so does phosgene. Now, watch closely. An OH group from bisphenol A and a chlorine atom from phosgene are attracted to each other. They break off and combine to form a tiny molecule of hydrogen chloride, which is the condensation part. The larger pieces that are left behind now have a place to join together, creating a strong carbonate link. This process repeats hundreds or thousands of times, creating one incredibly long, stable chain of polycarbonate. This chain structure is what makes it so tough. Because of its unique blend of toughness and clarity, polycarbonate is a true engineering superstar. It's used to make shatter-resistant eyeglass lenses and safety goggles. It's the material used for CDs and DVDs, where its optical purity is essential. Because it's strong and lightweight, car manufacturers use it for headlight covers and dashboards. And that bulletproof glass we mentioned? It's typically made from layers of glass and polycarbonate. The glass provides hardness, while the polycarbonate provides the impact strength to absorb the energy. All right, let's pause for a quick knowledge check. This is the kind of question you might see on an exam. Q. Identify the polymer type of polycarbonate and its key structural and recycling characteristics. Let's break it down step by step. First, can we melt polycarbonate down and reshape it? Yes, we can. That makes it a thermoplastic. Second, what does its molecular structure look like? It's made of long, individual chains that aren't chemically linked to each other. This is the definition of a linear polymer. Finally, because it's a thermoplastic, can we recycle it? Absolutely. Melting and reforming is the basis of recycling for these materials, so it is recyclable. So, the full answer is polycarbonate is a linear thermoplastic polymer that is recyclable. Simple as that. A common point of confusion for students is the difference between thermoplastics and thermosetting plastics. Here's an easy way to remember it. Thermoplastics, like polycarbonate, are like chocolate. You can melt a chocolate bar, reshape it into something new, and let it cool. You can do this over and over again. Thermosetting plastics, on the other hand, are like cake. Once you bake the batter, the chemical change is permanent. You can't unbake a cake and turn it back into batter, just like you can't melt a thermoset. Remembering that simple analogy can save you a lot of confusion. So let's do a quick recap. Today we learned that engineering thermoplastics are a class of high-performance plastics that are stronger and more durable than everyday plastics. We focused on polycarbonate, a superstar material known for its glass-like transparency and metal-like impact strength. We saw that it's made from two monomers, bisphenol A and phosgene, through condensation polymerization. And we explored its incredible applications, from eyewear to automotive parts to bulletproof glass. If this video helped simplify things for you, please hit that like button, subscribe to the channel for more engineering content explained simply. Do you have a question about polycarbonate? Or is there another polymer you'd like to see covered? Let me know in the comment section below. Thanks for watching, and I'll see you in the next one.